Okay, where we can apply this trigonometry. That is the main concept. We can study this application of the trigonometry to find the height of the mountain peak or anything. Height of the building, height of the pole, height of the tree. Such cases, we can apply this trigonometry application. Okay. In these two types are there. If we can stand on the earth and see the highest mountain peak or height of the peak of the pole or height of the building, in such cases, we can take the angle. That angle is called as the angle of the elevation. Okay. In these two types are there. One is angle of elevation, angle of depression. Angle of elevation is nothing but the line of side, the horizontal line, and angle between the line of sight and the horizontal line is called angle of elevation. Here, suppose we are seeing a person is seeing from this, and this is the height of the tree we are taking. Here the peak is, the top height is the height of the tree. We are seeing from here means from the horizontal line with the line sight, that is called as the angle of the elevation theta. The line of sight, the horizontal line, and the angle between the line of sight and the horizontal line is called the angle of elevation. That is nothing but the angle in between of the horizontal line and the line of sight. This is called as angle of the elevation. The next definition is the angle of depression. This angle of depression means the angle in between the line of sight and horizontal line is called as angle of depression. Depression means we can see from the top, and to find the height, we can stay at the top of the building or top of the pole, whatever it may be. From that, we can see the horizontal line. The angle, we are here, okay? From the horizontal line means where we are seeing the position, that is the horizontal line. From that to bottom, that is called as the angle in between of the side of the line or the line side and the horizontal line angle is called as the angle of the depression. That is nothing but we can write here the angle between the line of sight and the horizontal line is called the angle of depression. That is nothing but, suppose we are standing on the top of our school building or whatever it may, our building, and we can see the stone on the earth. In such cases, we can find the angle in between of the line of sight and the horizontal line. This is also called as the angle of the depression. The definition of angle of elevation and angle of depression both are same, but seeing positions are different. In the angle of elevation, we are on the earth. We are on the earth. In the seeing of the particle, we are on the top of the building or top of the pole or top of the temple, whatever it may be. From the top to bottom, that is angle is depression. From the bottom to top, that is angle is elevation. These two are very, very important. From the theory of elevation and depression only we can get the answer, and that is related to this application of the trigonometry. Okay, the drawing style is very, very important. Here, drawing figures to solve problems. These are depends on following conditions. Okay. The first problem is the top of the clock tower is observed at the angle of elevation of alpha. Angle of elevation means first we are draw the tower, clock tower. Clock tower is, this is the clock tower. Okay, this is the clock tower. Here the angle of elevation means we are on the earth and we can see the top of the tower. That angle is alpha. That is nothing but the foot of the tower is at small d distance. This is the foot of the tower and we are staying here, and we can observe some distance from the foot of the tower. That distance is small d, and from that distance we can see in the top of the tower with the angle of elevation. That is nothing but, here alpha is the angle of elevation. The horizontal line means the joining of the our foot to the foot of the tower, that is the horizontal line, and the angle alpha is in between of the line of sight and the horizontal line, that is the angle of the elevation. This is the figure. Okay, here alpha is equal to angle between line of sight and horizontal line. Suppose we can take AB is the tower height. Let it be small h, and our point position is C. Then AC equal to distance in between foot of the tower and observer. Okay. Alpha is the angle between of line of sight and the horizontal line. This is the diagram for the given data. Here, the top of a clock tower is observed at angle of elevation. Angle of elevation means we can observe from foot of the any mountain tower, whatever they are asking. And that foot to our observer who are observing, the distance is small d. Okay, that is the observer. The distance of tower to observer is small d meters. The angle is alpha. Okay. The second problem is Rinky observes a flower on the ground from the balcony of the first floor of a building at an angle of depression beta degrees. The height of the first floor of the building is x meters. Draw the diagram for this data. If it is the building, in this is the first floor. This is the foot of the building. And she observes a flower on the ground or on the ground of the park or whatever it may be. But this is the first floor. They have given the height of the building from the first floor is small x. That is, the height of the first floor of the building is x meters. We can take this is the x meters. And from the observer to that object distance from the foot of the perpendicular is, they didn't give any clue. But here, where the Rinky is observed, from that we can draw the horizontal line. So from this horizontal line to that object angle is beta degrees. So this is the angle of the depression. Okay. Rinky observes a flower on the ground from the balcony of the first floor of a building at an angle of depression beta degrees. The height of the first floor of the building is x meters. Draw the diagram for this data. This is x and this is beta degrees. Okay. Here, suppose we can take A, B, C is there. So the beta degrees is equal to same. We can take, this is the angle of depression. X is equal to height of the building.
84950.
Okay. This is the
entertainment apps for Maja. Okay, set up box low. Kevalam 2999K.
The first to read out the problem. A large balloon has been tied with a rope and it is floated in the air. Okay. This is a balloon floated in the air. A person has observed the balloon from the top of a building at angle of elevation. It is the top building. Okay. This is the rope tied with the balloon. And he or she is observing from here, top of the building to at the elevation of theta1 and the foot of the roof at the depression. This is the horizontal line where the observer is observes, that makes a horizontal line, and the angle in between of horizontal line to the rope tied where the balloon, that is called as the angle of elevation. That is from bottom to top angle is angle of elevation. Next, the foot of the rope at the angle of depression of theta 2. This is nothing but theta 2. This is the depression. This is the horizontal line. It makes the horizontal line. And this is the foot of the balloon. So the height of the building is h feet. This is the h feet. Draw the diagram for this data. Okay, this is the diagram. Okay, here we are taking, this is the building height, means we can take, it is also, we can take like this only, observes, that is from line only. This is the height of the building. Suppose we are taking AB is the height of the building, CD is the height of the balloon, E is the horizontal line. Here BE is equal to horizontal line. Here, angle DBE is equal to theta 1, that is angle of elevation. Angle EBC equal to theta 2. Angle of depression. AB is equal to H, that is the height of the angle, height of the building. Okay. Again, you read out the question. A large balloon has been tied with a rope and it is floating in the air. Okay, this is the tied thread. A person has observed the balloon from the top of a building at the angle of elevation. This is the building height. Angle of elevation theta 1. And the foot of the rope at the angle of depression. This is theta 2. The height of the building is h. Draw the diagram for this data. When you get the clear picture from the given data, then you can easy to find out what they are asking. What is the angle of the elevation? What is the building height? What is the distance from the foot of the rope to observer? These all are calculated from this given information only. When you can draw the correct figure, then you get easy values and correct values. Okay.